All right, today we're going to talk about solutions and mixes, and I'm going to be honest with you. This is a kind of tricky and a little bit weird topic. So I need you to bear with me, and yes, I know we are not in science class, but you know, we're doing this here. So just be open-minded, okay? In order for us to do these kind of systems, I need to start by doing a recap about percents. So we're going to take it way back, all the way back to 6th grade. We're going to talk about percents. Okay, a percent is part of a whole, and it can be solved in many ways. Remember, percent is a fraction, a ratio out of 100. Okay, so it's percent out of 100. So if I have 50%, that's 50 out of 100, which reduces to 1/2. If I have like 60%, that's 60 out of 100, which reduces to 3/5. Okay, so a percent is a fraction written out of 100, and we write it as a percent because we just do, okay? So we can solve them in many ways. The first way that we learned was to solve them as a proportion using scale factor. And then some of you came across solving using cross multiplication. So we didn't necessarily teach you cross multiplication, but some of you saw it in a book or you see your parents taught you, which is fine, as a strategy to solve a percent that's written in a proportion form. And then when we started talking about tax, tip, commission, discount, you started writing total times the percent written as a fraction. So let's say I have a $50 shirt and it's 20% off. I would do 50 times 0.20, and that would be my discounted shirt. And my discount would be 50 times 0.20 is, well, it's $10. So I would get $10 off. Okay? So that's how that works. Now, now the example that we're using now is not T-shirts and it's not discounts. It's a little bit weirder. So in this example, let's pretend that I have a giant bucket or vat. Let's say I have a huge barrel of 50 liters of this liquid, and it's a solution. And this solution is 20% peroxide. So I don't know what else is in it, but I know that 20% of what's in that barrel is peroxide. So I want to figure out how much of what's in that barrel is peroxide. Okay? So I know that it's a solution that's 20% peroxide. I want to know exactly how many liters of that is peroxide. So what I would do is I would take the whole amount, which is 50 liters, and I would multiply it by 20%, except I would write that as a fraction. Because remember, we don't do, not as a fraction, as a decimal. Okay? And yeah, total is percent. This should be decimal too. Okay, so I would write it as a decimal. So it would be 50 times 0.20. And when I put that in my calculator, let me just make sure. 50 times 0.20 gives me 10 liters. Okay, so that means in that entire huge thing of peroxide, of whatever this mysterious solution is, 10 liters of that big vat is peroxide. We don't know what the other 40 liters is, but that's peroxide. Okay? So, what I want you to do right now is I want you to solve this other question. So I'm going to give you another question right here. Okay, so let's pretend I have 90 quarts of 22% butterfat cream. I want to know how much is butterfat. That's all I want to know. How much is butterfat? If 22% of this cream is butterfat and you have 90 quarts, how much is butterfat? So take a minute now and I want you to do that math for me. And again, I'll put this, remember, you're going to take the whole times the percent written as a decimal. Take a minute and do that now. Okay, so what I'm hoping that you just did was you said, okay, well the whole, where did it go? The whole is 90, and I want 22% of that, and if I write that as a decimal, it's 0.22. When I put that in my calculator, 90 times 0.22 is 19.8 quarts of butterfat. That is a lot of butterfat. Okay, so that's what we're going to be doing today. We're going to be solving equations and situations that involve mixing things together. Okay, so today up here what we have is we have peroxide. So what we're going to do is we're going to see equations where we're going to see situations where I'm taking two different mixtures. So I'm taking maybe one that has 30% peroxide and one that has 10% peroxide, but I want this 20% peroxide mix. So I'm trying to figure out how much of each of them I have to dump in. If I got like 25% butterfat cream and like 15% butterfat cream, how do I need to mix them together so the resulting butterfat is 22%? So that's what we're doing today. Okay. Now, these are slightly weird equations, so let's just talk about them. Let's go through them. Let's look at the situation first. Okay. So, first thing I see here is, and these are the notes we should have put in our notebooks earlier today. I think they're on purple paper. So, a chemist needs to mix 50 liters of an antiseptic solution containing 20% peroxide. How many liters of the 25% peroxide solution and how many liters, oh, that's better, of the 15% peroxide solution are needed to accomplish this task? So when we solve a problem like this, so again, this is just like that thing. He's got this giant bucket of 20% peroxide solution. He needs to fill this bucket up, but he doesn't have 20% peroxide. He only has 25 and 15. So he's trying to figure out how much of each he needs to pour into this bucket so that he has the solution that he needs. Okay, so we're going to start by defining our variables. So what do we not know? Why don't you take a minute and write down what you think our variables are. Okay, so the first thing we don't know is it says how many liters of 25% peroxide solution and how many liters of 15% peroxide solution. Okay, so we're trying to figure out how many of each of these I have to dump in to work it out so that it works out to be 20% peroxide. So my first variable I'm going to say is liters of 25% peroxide. And then my y is going to be liters of 15% peroxide. Now, why would we do this? Well, I don't know. I'm not a chemist, but I assume this is something that we do. Okay? So, let's think about what our equations are going to look like. So, what do we know? Well, we know that he's making 50 liters. So if I add these liters and these liters, it should equal 50. So x plus y equals 50. Why did I not use like other letters besides x and y? Why don't you take a minute and tell me why you think I didn't use letters besides x and y? Why I use x and y? Because you know I'm not a huge fan. I like to use descriptive variables. So tell me why you think I didn't. Okay, the reason why I didn't use descriptive variables is because, like, what am I going to use? I have liters peroxide in both of them. I have 25 and 15. I mean, I can't use a number for my variable. So using a letter is the only option that I have. All right, using x and y is the only option I have because there's nothing going to really describe them, which, again, as I've said before, makes it critical that I define my variables. Okay, so now I've got x plus y equals 50. Now, this is the tricky part. Okay, so now I'm trying to write the amount of peroxide I'm going to wind up with. So I'm going to write one equation tells me how many liters I've got, and one equation tells me how much peroxide I have. Okay, so in the 25% peroxide solution, remember, if I want to know how much peroxide there is, I take the whole times, I don't need that parentheses by the way, times the percent written as a decimal. So 0.25x is going to tell me how much of this solution is peroxide. Okay, well, this solution, 0.15y, tells me how much of this solution is peroxide. And if you recall, over here on this paper we just did, we calculated how we were going to figure out how much of the whole amount was peroxide. Well, we're going to do the exact same thing here. We're going to say 0.20 times 50. Okay? Because I want to know if I take the amount of peroxide in x and the amount of peroxide in y should add up to the amount of peroxide in the whole thing. Okay? So the first solution tells me how much total, like, liters or whatever, like if I'm mixing up pecans and, I don't know, like, you know, pecans and peanuts, you know, what percent of them is pecans and what percent is peanuts, and then what percent of the total. So I want to know that, so the first the first equation tells me how much total, the second equation tells me how much peroxide. Okay, so now let's try solving it. X plus y equals 50. 0.25x plus 0.15y equals 0.20 times 50. Okay, so there's a couple things going on. I kind of end up needing to transform both of these equations. Okay, this one I need to scale up. I need to scale it so they have the same, so that I make a zero pair. Okay, so I'm going to multiply this top row by negative 0.25. Well, that gives me negative 0.25x minus 0.25y equals, and I got to figure out what negative 0.24 times 50 is, which is negative 12.5. Okay, now for this one, I'm going to rewrite this one, but I need to kind of fix that. Okay, so that's 0.25x plus 0.15y equals 0.20 times 50, which is 10. Well, now I can solve this just the way we have been. This zeroes out. Negative 0.25 plus 0.15 is negative, oh my goodness, negative 0.10y equals negative 2.5. Divide both sides by negative 0.10. And I get y equals 25. What does that mean? That means I have 25 liters of 15% peroxide. Now what do I do? Remember, they want to know what both of them are, so I got to go back and find x. Well, this is a good looking equation right here. Okay, so x plus y equals 50. Well, x plus 25 equals 50. X equals 25. Okay, so I think I need 25 liters of each. Well, I'm going to check. I'm going to substitute it and check. Okay, my final substitution is 0.25 times x, which is 25, plus 0.15 y, which is 25, should equal 10. Okay, 0.25 times 25 is 6.25. And then 0.15 times 25 is 3.75. And when I add them together, I get 10, and that is a true statement. So I have 25 liters of 25% peroxide, and I have 25 liters of 15% peroxide. Now, I hated every minute of doing that equation. Can anybody tell me why? I don't need to ask y'all a question about this. You know what I didn't like. I did not like these decimals. So when we do the next problem, I'm going to show you how to scale up your equation so that you don't have to deal with those decimals anymore, if you choose to. Okay? So, let's talk about this problem right here. It says, so this one we kind of hinted at earlier as well. It says a milk distributor has cream that's 24% butterfat and another cream that's 18% butterfat. How many quarts of each cream must be used to obtain 90 quarts of cream that's 22% butterfat? So this is what I'm trying to get, 90 quarts of 22% butterfat. Okay? So the first equation is going to be just like quarts total. It's going to be quarts of cream. And the second one is going to be butterfat. Okay, so we have one that gives us our total amount, which is 90. The other one gives us 22% of 90, because I want to know how much, just the fat. Okay? So take a minute. I want you to define the two variables. Okay, so hopefully what you defined was that the first one of them is 24%, well, let's say quarts of 24% butterfat cream, and the second one is quarts of 18% butterfat cream. Okay? So how am I going to find my total quarts of cream? Take a minute and respond to the question that pops up. Okay, well, what I ought to do to find my quarts of cream is add up my quarts of the, so my total quarts, I want to have 90 quarts. So if I take my 24%, which is my X, and I add up my 18%, it should equal 90 quarts. Okay? Well, how much of that's butterfat? Well, 24% of that, of X is butterfat, and 18% of Y is butterfat, which should give me 22% of the whole 90. Okay? So, you'll get used to this. We're going to practice this. You'll get better and better at it. Okay, so let's take a look at this one now. Now let's try to solve it. We have X plus Y equals 90, and we have 0.24X plus 0.18Y equals 0.22 times 90. Okay, I do not like these decimals. Okay, now what's going to wind up happening is we're going to have some big numbers, but that's okay because I do not like these decimals. Okay, so what I'm going to do is I'm going to multiply these by 100 because these are hundredths. I'm in the hundredths place here, so I'm going to multiply everything by 100, and that's going to get rid of these decimals. So what I'm ultimately going to be doing is moving the decimal 2 places to the right. I'm going to move this one 2 to the right. Which is 22 times 90. Okay, so when I do that, that's a lot easier to work with. Okay, so what is 22? Let's start by like kind of simplifying this one. That's 24x plus 18y equals 22 times 90, 1980. Okay, now for this one, I want to eliminate something, so I'm going to multiply this entire top row by negative 24, which gives me negative 24x minus 24y equals negative 2160. Okay, so I'm going to zero this out. Negative 24 plus 18 is negative 6. Negative 2160 plus 1980 is negative 180. When I divide both sides by a negative 6, I get y equals 30. So I know right here I have 30 quarts of 18% buttercream. And again, the second I get this, I'm going to write it up there because I want to keep track of it. When I'm using X and Y, I really try to keep close track because otherwise I'm going to lose them. Okay, then the next thing I'm going to do is I'm going to use this equation here, x plus y equals 90, to figure out how many quarts of the 24% I need. Well, x plus 30 equals 90. X equals 60. So right now, I think I need 60 quarts of 24% and 30 quarts of 18%. I'm going to check. Now, I'm not going to use this. I'm going to use that. 24 times x, which is 60, 0.24, plus 0.18 times 30 should equal 0.22 times 90. So I am literally going to put exactly that into my calculator. I'm going to put, well, not the equal sign, obviously. I'm going to put 0.24, 0.24 times 60 plus 0.18 times 30, and I get 19.8 over here. Then I'm going to do 0.22 times 90, and I get 19.8. Is that a true statement? Yes, then it checks out. So what that means is I have 60 quarts of 24% butterfat cream, and I have 30 quarts of 18% butterfat cream. We will practice this, okay? Don't think this is all you're going to see, but I want you to see these two examples. Come in tomorrow with questions. Make sure you make notes. Watch again if you need to.